Hey everyone, my name is Roman, I work at Osmonic, and today I'll present to you the wit-deps tool that I have developed recently. So when we started integrating a component model on our host side and guest side, we quickly realized that it's quite difficult to keep our dependencies in sync in any reasonable way, to actually maintain that stuff and make sure that if there's a new update to any WASI-Cloud interface we depend upon, that we actually can pull that update in and manage all of that. So the wit-deps is the tool which is meant to address exactly that. So let's look at an example world. If we had something like this here, where we depend on multiple WASI-Cloud interfaces like the clocks or HTTP or messaging. So in order for the wit engine to be able to actually consume this world and produce bindings for us, let's say in Rust, like this example is, then we would need to have deps directory on disk containing sources of all of these interfaces, but also sources of their dependencies, right? So we need to have the whole flattened dependency graph on disk. And that's just how wit-binding works today. It's actually going to change, and eventually you're going to be able to just pull dependencies from a registry. But today you need to have this structure. And we can look at what it actually looks like. So this is what wit-binding actually expects, is this wit-deps directory with, say, in our case, clocks, HTTP and I/O, and any transit dependencies or far dependencies. So naturally, it's not the easiest, or maybe not the nicest job to do, to go and iterate through all the dependencies of your dependencies, to resolve all of this graph, and copy paste these things or add these as Git submodules or Git subtrees or whatnot. So in order to make that all simpler and more maintainable, wit-deps uses with dependency manifest, which is essentially just a key value mapping the names of dependencies to their sources, right? In the simplest form is just a URL to a tarball, and that's actually plays very nicely with, for example, GitHub, where in GitHub you can get gzip tarball of any branch or tag or commit reference, for example, which means you can actually now consume any of the WASI-Cloud interfaces directly as you wish, right? You can also pin to particular hashes of expected sources of that tarball, right? So for example, in this case, we can pin the key value interface, key value with package, if you will, right, to this exact commit revision, and we expect the digest of that tarball to be exactly this SHA-256 and this SHA-512, right? So, but it's not necessary, right? You can also just pin even to a dynamic branch like main, which will change over time. Even though it will change over time, wit-deps will actually lock all of our everything that we actually have in our wit-deps. So it's going to compute the digest of unpacked contents on disk, right? And so if, for example, we depended upon, here for HTTP, for example, if we depend on the main branch of WAS HTTP, but we have it on disk and we have the log file, then it will not actually do anything even if we try to repopulate our dependency directory, right? Because it's going to make sure that, yes, so the URL is in sync with what we have in the manifest, and the contents also match what we have in the log. That means that it's all in sync. So now let's see a little bit how it actually works. Let's start by just removing our deps directory, and so I have my normal Rust binary using wit-bindgen. I can show it here. So it just uses the wit that we have over here. And then we have our world we already seen, and the dependency manifest and the lock. So let's say, so the lock will be generated if I don't have it. In fact, let's try to remove it. It may, so since if I remove the lock, it will actually maybe regenerate some of the dependencies, right? So that's it. So I ran wit-deps and it populated my deps directory, and it wrote a new lock, and well, it just parsed my manifest file and just populated everything. In fact, all my dependencies were already in sync, so I didn't actually do anything. So wit-deps is a part of Bytecode Alliance now. It's a Rust project, as I said, so you can simply install it as cargo install wit-deps CLI, and you're going to have wit-deps in your in your path. So there's also wit-deps update exactly for the use case of using these dynamic references. And oh, it's a new one. So apparently there is incompatibility between two different poll dependencies. So that's why actually it asks me to, well, resolve that dependency. In fact, I didn't expect this to happen, but it'll be a great thing to show. So let's say I would want to pin my. What this means is that because wit-deps also pulls in transitive dependencies, there were two different versions of poll being dependent upon by my dependencies, so it didn't actually do anything about it. And now I just have to go to my deps.toml and pin what's it called, a particular version I want, but I just hope that the main branch is going to work. So let's try it again. So now if I do wit-deps update, you see now it actually succeeded. And I actually did not anticipate this. I was not expecting this to happen, so it's interesting demo effect over here. And it's actually a great example. We can also check what happened with our log file, and we can see that now the poll actually is removed from our deps key in the log, because now we actually explicitly specified where the poll comes from, and so it was not pulled in transitively by our dependencies anymore. You can see also all the changes that we have here in our dependencies. Yeah, so I guess that's about it. One thing I have to mention then, that wit-deps today is just intermediate kind of tool for status quo and where we are today. Eventually, we have some ideas of how this could evolve into just general purpose wit tooling used by host runtime authors, or let's say these quasi-cloud interface authors. So essentially what we would do, it would, well, first of all, it would be able to, once wit-bindgen can speak WASM, right, for dependencies, then wit-deps can also pull in WASM binaries rather than tarballs of concatenated wit files. And at one point it's also going to be able to just pull stuff from the registry, since we expect all of these interfaces to live in, I suppose, work registry, but an arbitrary WASM registry. So wit-deps should be able to just pull those dependencies in. And so eventually, once we have things like cargo component and other different component tooling, then the guest component authors are not going to use any of this, right? So they're going to just pull the interface directly from the registry. But this is going to be a tool which is going to be used again by host developers or the actual wit people who actually write wit. They're going to use this tool most probably, or at least that's the idea. And kind of the use case you could think about is, let's say, if you wanted to define an RPC service, right? And you would be able to, for example, generate your protobuf, gRPC service definition from your wit definition. So this is a kind of scope where like this general purpose wit tooling could live if this is something we want to do, right? But this is that's kind of the scope. So you're welcome to also check out some issues if you want to contribute, or if you want to just play with this, just please check out the repository. And as I said, like the immediate, like the short-term goals is what we want to have is to be able to consume WASM and produce WASM as output in order to be able to test your wit definition, your wit package. Thanks.